All right, welcome. If you're joining on YouTube, this is the Paraxialio 2.0 demo. This is a live recording of a webinar that took place in December 2023. My name's Michael Lubis. I'm the founder of Paraxialio. My whole professional career has really been in software security. I learned Elixir a few years ago, and before Paraxialio, there was really no comprehensive security platform for Elixir on the market at all. You could piece something together with open source tools, but if you actually wanted, help with Elixir security, which is very important for many businesses, vendors would have not really supported actually. There was just really nothing good on the market. So with that, Paraxialio, it's an Elixir security platform. I'll be showing you 2.0 of it today. That's the software. Also through Paraxialio, there's Elixir developer security training, which is helping people understand more about security through hands-on training. And then also available is general consulting, penetration testing services. If you have like a SOC 2 audit or something coming up, we also can help you with that. So for some context today, I'm going to be showing you Paraxialio, but I want to explain really why do businesses buy this software and why is it relevant for their operations. So most companies today have a web application that faces the public internet. And this is going to be the part of cybersecurity we're really concerned with today. So sometimes you might hear about like cell phones being hacked or your laptop, like there's malware on somebody's computer. That's very important, but that's not really in scope for today. We're focused on a company is developing software in-house. They're writing a web application and either selling it to someone or putting it on their own network facing the public internet. And that code is going to constantly get attacked because as soon as you put anything, on the public internet, let's say you register a domain name or do like a TLS certificate, that information gets published. And then there's servers that are just constantly checking for like new registrations. And then they immediately go out and scan that for vulnerabilities. They try to take over the web server and, add it to their botnet or try to harvest some useful information out of that. So really anything you put on the public internet is just going to get attacked constantly, really, whether you like it or not. So what does this mean for like a business that's, using Elixir in production or really any software to make a web application? Equifax learned this lesson in a very hard way in 2017. They suffered probably the highest profile data breach ever. And it was due to Apache Struts, which is a Java web framework. So it's kind of like Elixir to Phoenix, Ruby to Ruby on Rails. You have Java and Struts. It's the same relationship. Essentially, Equifax is a big company. They lost track of where they were running Apache Struts. This very bad vulnerability came out for remote code execution. And that's how the bad guys got access to the company. More recently this year, 23andMe suffered a data breach, but the method the attackers used was a little bit different. So they didn't compromise the underlying web server. Rather, they used an attack called credential stuffing. And that's where you don't really exploit like an OWASP style, like RCE or SQL injection. That's literally just sending like web traffic to an application, like send 100 login attempts. It's pretty simple. You could describe it to somebody, but it's really, really effective. And now they're suffering like the consequences of the data breach. It's really bad for their business. So any company that has a public-facing web application has to deal with this problem, whether they like it or not. And securing a web application is actually pretty difficult. It's simple in the sense of if you know what you're doing, the steps are pretty straightforward. The problem is it relies on compatibility and there's a lot of things that just go into it. So maybe each individual piece is simple, but I would say getting the whole thing right and covering all your bases, that's very complicated. And I have a picture of an elephant here because I like the analogy of the blind man and the elephant, where everyone sort of has their own piece of it. Where for Equifax, you could say it was asset management, where they weren't, keeping up to date on things. But you could also argue maybe that was like static analysis, like they should have been checking the code. for security vulnerabilities, or they should have had runtime protection. With 23andMe, that was more of a bot defense thing where they could have been checking things at runtime. There's another thing called WAF, which isn't even up here. I think I ran out of space. That's how many acronyms there are in security industry land. The thing is, if you are, a person that's responsible for the security of web application, and you sit down and go, okay, I want to ensure that this is safe. Like, what do I do? You might go out and talk to some vendors, and you can kind of go broke doing this because there's like a million of them. And none of these have good Elixir support too, because the slice of the industry is too small for them. Essentially, when you start a cybersecurity company, your goal is to kind of fit into like a category. So you're SNCC and you want to do like security checking of dependencies. And your goal really is to have that contract for like a Fortune 500 company where you're like their secure package vendor, like you do it across the whole company. But for like a web developer or like somebody that owns a web application, now you've got to use like 8 different vendors, and it's kind of nonsensical because it just creates this like puzzle piece of too much complexity, really, is the problem. And that's what I created Paraxialio to solve, where you have an Elixir application. It has to be secure. What if there was just one tool that did all of that? And it's really not that complicated. It makes sense when you think it through. You just don't see other security vendors focusing on a vertical. In this case, the vertical is Elixir. They all want to like slice horizontally and go for like the huge VC valuation, which really, really hurts security and customer experience. I've been a customer of some of those vendors, and it sucks because you know that their target audience is really not you, like the person using it. You get the sense that they're not really focused on like the whole picture of security. So that's what I want to show you right now with Paraxialio. This is the site's overview page. So let's say you're running Elixir in production. Let's say you just have one code base. I have a few here, like Black Hat projects. The thing is, that one code base is going to be deployed in different environments. You're going to have a staging and dev and prod, and those might be different because you have different development branches. And really, the information you want to know for each of them is, does it face the public internet? Because that's where the attacks are coming from. And what are the current findings? I've seen a lot of other vendors do like code level where all they're looking at is their repo. And they try to sell that as a benefit, and it's really not, because what actually matters is when you deploy the code and it's facing the public internet, and then now that deployed instance is actually the thing getting attacked, and you have to defend it against, these types of threats. So this is the all sites page. This is your overview. And then this is what like one site looks like. So I have bells here. And on the left, I have application secure. That's really like the Equifax type of attack. On the right is bot defense. That's a 23andMe style attack. So starting with application secure. When the vulnerability in Apache struts that Equifax got hit by, when that dropped, suddenly every security team that knew they had Java like running in their company, their number one priority that day was like, go find all the Java and make sure that the version of Apache struts is like above, 2, 4, whatever. And it sucks because, as you're doing this work, somebody is scanning the internet and could have already compromised your whole, network. It's terrible. You don't want to be doing this on the day a big vulnerability drops. And with Paraxial, all you have to do is install it. It runs as normal Elixir code, and I'll go into detail in the live demo, but it just gives you all of the information you need to effectively make that decision. So let's say there's a huge vulnerability in Phoenix tomorrow. Like 1.6.12 is vulnerable to remote code execution. Okay, I just look at my dashboard. I'm like, yep, 14, we're fine. That's what you want. You do not want to be like having to check things at runtime. It sucks. It's horrible. So that's the kind of asset management part. Next up is the actual like compile time scanning. So this is code scans. It's checking that your actual source code that you're writing in Elixir, like for a Phoenix app, as well as the dependencies are secure. And I'll go into more detail about this too, but essentially you basically want those prioritized, and you also want to be sure that you're checking code before it goes into production. You want to be able to make sure during development, you're not introducing new vulnerabilities. Finally, this is exploit guard. This is pretty cool. So in this situation, you're already vulnerable to like remote code execution. It's deployed. You're basically a step away from Equifax already. So you're very bad. But Paraxial can actually at runtime tell you, hey, you're safe. We detected the attack and we blocked it. It's fine. So that's application secure. Now, bot defense is more of the 23andMe style attack. If you ever have to do like a reCAPTCHA where you have to solve all the fire hydrant stupid puzzles, I see ones now where they're AI generated and I hate them. That's what they're trying to defend against, is essentially a bot attack. With Paraxial, you actually don't need a CAPTCHA, which is really nice. And I'll show you how that works during the call today. But essentially, you can define rules. Here are some examples where like somebody was trying credit card fraud or credential stuffing. Really, if your web app has a login page or processes credit card transactions, even if you're outsourcing it to something like Stripe, if somebody writes a bot to do credit card attempts, your Stripe account can get banned and like your whole business shuts down, because how are you going to do transactions? So it's really, really bad. These bot attacks can like cripple like an online shop or a business. So that concludes the PowerPoint. Now let me show you the real live demo. So you can see here, this is Paraxialio 2.0, and this is our all sites page. So you can see we've got the environments, web facing, when the scan was last run. I want blackcapprojects.xyz right here. And you can see this is our page. Environment is production, it's web facing, and I'm currently a site admin. Here is the library count. So this is the app audit feature. It's actually pretty cool just because you can see like what is installed. Like the first time I ran this, I just spent like a few minutes reading through it. I had no idea like all of this stuff that was actually underpinning my Elixir app. So this is just kind of interesting. But it's also useful in that situation where a big vulnerability comes out and you have to respond very quickly. The next feature I want to show is the code scans. So you can see I've got 8 total vulnerabilities here. Code scans is right here. So under the hood, this is using Soblo, and it's checking for vulnerable dependencies and retired dependencies. And if you're thinking, well, Soblo is open source, like why would I even use it? The thing with Soblo is that, like, I'll give you an example Soblo finding, like MISC, like bin to term, unsafe binary to term, or like missing CSRF protection. And it's like, okay, that's cool. What's the severity of it? Like, how do I fix it? Are questions you probably have, because Soblo doesn't tell you that by default. It doesn't assign a vulnerability priority. It just has a confidence score. So what Paraxial does is it'll actually tell you, hey, this is what cross-site request forgery is. Here's the impact if you're vulnerable to it. And here's how you actually verify that, you know, this finding is relevant for you. And here's how you fix it. So this one's actually really simple. It's a one-line change in your router. But this just saves your development team a lot of time, where instead of like digging through and Googling all this stuff, and they're going to find the Paraxial blog anyway, because most of the blog is just me writing about this, they can actually fix the problem sooner. So the way this works, it's a normal mix task just in your terminal here. So let me do ls. You can see this is like a normal just Elixir application. And I'm going to do mix paraxial.scan. This is running, and now it's going to upload the scan to the Paraxial backend. I can refresh it here. And it also keeps a record of it for like SOC 2 compliance. So all of this is public. It was in the 2.0 announcement. I'm going to show you something that I finished literally this week, and I'm very excited. No one's seen it before. And it's going to be pretty big, I think, for application security, especially in Elixir. So that is going to be the Paraxialio GitHub app. So you can see right here, I'm developing on, just GitHub. It's what everyone uses, or GitLab, same idea. And I've opened a pull request for a new feature. And you can see once I do that, my build actually fails. And then I get a comment from Paraxialio telling me that I basically failed the build. And I have like this is actually a lot of security problems. MISC bin to term, unsafe binary to term. If I just had Soblo in my pipeline, this is all I would see. And it would be with all these other findings. I'd be like, oh, great. Like, well, let's just skip it, kind of go from there. Paraxial is actually telling you, hey, this is really critical. You actually need to fix this. And it's actually pretty simple. You just use plug crypto non-executable binary to term. It's literally like a one-line change, and you avoid the Equifax breach. So I'm really excited about this. It is not live yet. It is still in development. But this is the first demo I've ever given of it. So you're all seeing this for the first time. And you can see security fixes. I just do a commit here. It scans it again, and then you're all good. So this essentially prevents you from introducing vulnerable code into production. I should also mention, from a user experience point of view, managers love stuff like this because naturally, you get kind of security metadata in the PR. When you're actually developing, though, it is very annoying when you have to wait for a CI run, because these can take like 5, 10, 20 minutes as your company gets bigger. And you really don't want to be like, oh, okay, I made a change, commit it. And you have to wait like 20 minutes to get the result. So that's why I mentioned the mixed Paraxial scan task. You want to run this locally, check to make sure that there's like no more findings. And then once you get this clean, push your commit to GitHub. It'll run in CI and you'll get the green check mark essentially. So that is what I've been working on with the code scanning feature there. And then the last thing I'll talk about is exploit guard. So you have all this protection in place, but let's say you just happen to have an app that is vulnerable to remote code execution for whatever reason. That's extremely bad. You're basically a step away from Equifax, and you really don't want that to happen. So what's cool about Erlang, which is like the virtual machine underneath Elixir, is it actually has really good support for tracing function calls. So it's possible through, this is exploit guard, it's the feature in Paraxial, to detect when a remote code execution exploit is happening at runtime. And this is through Erlang binary to term. You can essentially pattern match on the function call. So there's a rule in like the Erlang trace where it goes, if this call starts with 131.112, that's always malicious, trigger an alert for that. This won't throw false positives too. Like if you log in, like you SSH and you connect to an IEX session, this won't trigger. This specific behavior like never happens in Elixir apps. And when you see it, you really, really want an alert and you really want to fix it. But the nice part is while you're doing that, Paraxial can just block the attack for you. So you're safe. If you're curious, there's also more information on the Paraxial blog about the development for this. Cool. So that is application secure. And now I want to talk about bot defense. So you can see kind of like the dashboard here. These are HTTP requests, about 900 allowed, 90 blocked, 2 active rules. So there's 3 features I'll show on this call today. The first is just rules. And this is really just IP rate limiting, where you define a rule that says, let's see, block credential stuffing. So somebody does 5 login attempts in 10 seconds, you just want to ban that. That's malicious, right? But this is just like kind of basic IP rate limiting. You probably already have this in your app. What is the point of even like buying something for this? And really the benefit is when, an IP address gets banned is you want context about what happened. So for example, let's say you're a B2B company and you have a really important client that's all on a VPN and everyone logs in at the same time and their IP gets banned. And now that's like a business critical incident. And everyone's running around like, why can't our biggest customer log in? Security is probably going to get blamed, or engineering is going to get blamed for it. With Paraxial, you can actually see, for this IP address for the past 7 days, it's only been failed logins to like all of these random accounts. So it's actually malicious. It's a good ban. If you saw, though, no failed logins and only like successful logins from your biggest customer, you could very quickly just say, oh, okay, take this IP, put it on the allow list, or just delete it from the ban list. You're fine. This is what I really wanted. I've actually had to do this at my old job where I was like writing SQL queries to like map IPs to see if I could ban it because we had this really big customer that was really high priority and it sucked. So that's what this is doing. And also IP rate limiting seems very basic, but you absolutely want to have it in place because the day after like a 23andMe hack, I guarantee you the first thing that they're reviewing is like, okay, well, what was our IP rate limiting rule? And then they're like, oh, we didn't have it because like we were using reCAPTCHA, which you can bypass, by the way. There's like literally a company called 2CAPTCHA that you can pay and they'll give you CAPTCHA solves. Not a good security defense. So yeah, this is the like rules part of Paraxialio. It's also worth mentioning you can bypass IP rate limiting very easily by proxying your traffic through AWS. So, in this attack, every request was coming from the same IP, but it's actually really trivial to just put all your traffic through AWS here. So you see like all of this is the same IP, yeah? And then it's different IP, different IP, different IP. But, the upside is they're all from AWS. So Paraxial actually gives you like a function plug in Elixir where you just put it in like your login route and it blocks the attack completely. The implementation is pretty cool too. There's like a radix try, persistent term, if you care about that stuff. But essentially it's very, very performant. It won't impact customer experience at all. And you're actually going to be able to block. I've seen bank accounts actually be hacked, like very simple technique, but it works extremely well because a lot of companies don't have defenses for this. And you really, really should. So this is the second part of bot defense. The last example I'll show you is actually pretty cool. So this is the real Paraxial new user signup page, right? And I was getting this problem where I was getting like spam signups. And this feature worked surprisingly well. So here you can see there's like one form in HTML. This is like the main one, but then you can see there's like the second form, but it's actually not displayed. It's hidden. So when a bot is trying to like attack you or just spam you, they're going to just parse the HTML, get all the forms, and then spam the forms or try to brute force login on each form. The good news is only normal people would be able to see this sign-in form, and then bots will be able to see the honeypot form. So they submit that form, they reveal themselves as a bot, and you ban them, which is pretty cool. So with Paraxial, this technique is live. It works very well. I was actually really shocked at how well it worked, honestly. This is not like demo data. This is actually real attacks. I believe it's about 500 now, 600. Like 600 real IPs have been banned every day. I think the last one was December 18th. And these are the kind of attacks you see. So to summarize, the thing that Paraxial gives your business is really like total security of the web application in one place. It's natively designed for Elixir. So like the performance is good. It's actually going to be compatible. And also you're working with a company that really cares about security and understands your technology stack. Any other cybersecurity company, like Elixir is just not the focus at all, which is sad. But I really see an opportunity for, a way to benefit the community and increase adoption by having this really strong security product. And that will improve kind of the reputation of the language, where it's like, oh, like the Elixir web app, like, yeah, that's very secure compared to kind of other ecosystems out there. So that concludes the demo today. Thank you for watching. I'm going to stop the recording now.